Wind energy. The Earth's atmosphere is a gaseous layer that wraps around the Earth. It sits above the planet, held in place by gravity. Wind is air in constant motion. It is produced by the uneven heating of the Earth's surface by the sun. Since the Earth's surface is made of various land and water formation, it absorbs the sun's radiation unevenly. When the sun is shining during the day, the air over the land masses heats more quickly than the air over the water. The warm air over the land expands and rises, and the heavier, cooler air over water moves in to take its place, creating local winds. At night, the winds are reversed because of the air cools more rapidly over land than over water. This flow of air pushes off to the side as wind, to head back to where the cooler air came from. Wind is affected by both changes in pressure and temperature. When one area heats up more than another area that is next to it, the difference in pressure creates wind. And because the Earth is rotating, the air does not directly flow from high to low pressure areas, but is pushed to the right in the northern hemisphere and to the left in the southern hemisphere, causing the wind to actually flow around these higher and lower pressure areas. When these higher and lower pressure areas are close together, the stronger the wind becomes. The Earth's surface also plays a part in the wind's movement because friction from the ground will also slow down the wind's speed. Similarly, the large atmospheric winds that circle the Earth are created because the surface air near the equator is warmed more by the sun than the air over the north and south poles. In addition, the rotation of the Earth at 1,000 miles per hour helps to fuel the feeling of moving air. Wind can now come into contact with the windmill, beginning the transfer of energy. Wind moves over the airfoils. The blades are designed so as to take full advantage of the wind. The blades are more rounded at the top, taking advantage of the aerodynamic forces. These forces at work are lift and drag. Because of the rounded surface at the top of the blade, the wind flows faster over it, creating less pressure. Since there is now more pressure at the bottom, the lift occurs. Lift is perpendicular to the top of the blade's surface. The lift causes the blade to turn. Drag is the opposing force. It is the friction of the air against the blade's surface. It is perpendicular to the lift. Less surface area lessens the drag. The angle of attack is created by the direction of the wind and the tilt or pitch of the blade. If the angle is too great, it will cause the blades to stall. Also, if the angle of attack is too small, it will slow and cease the turning of the windmill, also known as furling. The location of wind farms must be planned out very carefully. Some good sites for these farms would be at the top of smooth, rounded hills, open plains or shorelines, and mountain gaps that produce wind funneling. Each turbine has 4 parts: the rotor, nacelle, tower, and the foundation. The rotor is in the front of the wind turbine and holds the blades. Each blade can range from 100 to 150 feet. The nacelle holds the shaft and generator that are used to convert the wind energy. The turbine works in the opposite way of a fan. When a fan uses electricity to make wind, the turbine uses the wind to make electricity. Inside the nacelle, the spinning rotor spins the generator to produce electricity. The generator converts the mechanical energy of moving into electrical energy that we can use in our homes. Depending on the size of the wind turbines, there may be a gearbox between the rotor and generator. This is to help the generator to spin fast enough to make electricity for the grid. The two parts of the turbine are the tower, which can be as tall as 20-story buildings, and the foundation, that is the base of the turbine. Wind turbines can create as little as 100 watts to as much as 5 megawatts. The top 5 wind power producing states in 2012 are Texas, California, Oklahoma, Iowa, and Illinois. In 2012, the U.S. generated 140 billion kilowatt hours from energy.